Okay, day 16. Hopefully it goes well. It says I have an excellent connection, and there it is. And yeah, so you know the drill by now. We are going to try and keep it simple and keep it simple. So yeah, our goal is to keep it simple, and let's see what the problem looks like for today. Hopefully it goes fast, because I like it when they go fast. So we're walking to another connecting flight. You realize that one of the ways rerouted trip is on a high-speed train. For the train ticket you're given is a language you don't understand. You should probably figure out what it says. Fortunately, you can't actually read the words on the ticket. You can't overread the numbers, and then you figure out the fields those tickets must have and the valid ranges for the values in those fields. You collect the rules for ticket fields, numbers on your ticket, and the numbers on other nearby tickets for the same train service together in a single document you can reference. The rules for ticket fields specify a list of fields that exist somewhere on the ticket and the valid range of values for each field. For example, a rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1 to 3 or 5 to 7 inclusive, such that 3 and 5 are both valid but 4 is not. Each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Each ticket has the same format. For instance, consider this ticket, something something. Here, question mark represents text and leads you to understand. This ticket might be represented as 101, 102, and so on. Of course, actual train tickets you'll get are much more complicated. In case you've extracted just the numbers in such a way, the first number is always the same specific field, the second number is always a different specific field, and so on. You just don't know what each means. Start by determining which tickets are completely invalid. These are tickets which contain values which aren't valid for any field. Ignore your ticket for now. For instance, suppose you have the following notes. Class 1 to 3 or 5 to 7, your ticket, nearby tickets. It doesn't matter which position corresponds to which field. You identify nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true with the other three nearby tickets. The values 455 and 12 are not valid for any field. Adding together all the invalid values. Consider what is your ticket scanning rate. To begin with, get your puzzle input. So let's see. Okay. So first we need a data structure to parse all of this into. So let us capture this. And raw is this. And from typing import dict list named tuple, and let us say must have fields in the valid range. The rules, so what I will do is I'll say a class rule, which is going to be a named tuple, and it's going to have a name which is a string, and low which is an int, and high which is an int, and def parse, again I'll do this as always, static method parse from a line which is a string and is going to return a rule, and what we're going to do is as follows. Let's say range is a tuple int, because it's not just one low or high, it's actually going to be ranges is a list of range rule. And so can it have multiple ors? Looks like it can't, so but I'll do it this way anyway. So what I will do is I will say name ranges equals line dot split on colon space. Okay, and so I have the name already, and then ranges. I'll just do range 1, range 2 equals ranges dot strip dot split on or, and then let's say and let's say def make range s is a string, is going to go to a range, and let's say low high equals s dot split on a dash, I think, and then return int low, int high. Okay, and so now I want to return return make range s for s in ranges dot strip dot split. Return rule name equals name and ranges equals this. Okay, and so let me just try this out. And rule.parse of class. Okay, good. So that seems reasonable for now. And a ticket is just a list of ints, and let us say, I'll call it a class problem named tuple. Let's say rules is a list of rule, and your ticket is a ticket, and nearby tickets is a list of ticket. And then again, we're going to parse this from raw, which is a string, and is going to return a problem. So what am I going to do is I'm going to, this is very bad naming, ABC equals raw dot split on double new lines, and let's say rules equals rule dot parse line for line in a dot split n, def make ticket s, which is a string, and is going to return a ticket, and just return int n for n in s dot split on commas, I think. Yes. So rules equals that. My ticket equals make ticket b. Nearby tickets equals make ticket line for line in c dot split on new lines. ABC were stupid names, but that's fine. Return problem rules my ticket nearby tickets. Okay, so now let's say problem equals problem dot parse raw, and let us try this out. Invalid literal for base 10, your ticket and let's say b equals b dot split on b equals b dot split on new lines -1, and then again we want to get rid of the first line, which is okay, class 1 to 3, 5 to 7, row this rule your tickets, nearby tickets, and so on. And let me say is valid self I, which is an int, and it's going to return a bool, and it is valid if return any low is less than or equal to I is less than or equal to high for low, high, and self.ranges. So that will give me is valid. And now let me go back and return the problem. Say return tickets which are not valid for any field. Okay, so what I can say is valid for any field, I, which is an int, returns a bool, and return any rule dot what I call it is valid, yeah, is valid I for rule in self dot rules, and so I need to do a self here. Okay, and finally I want to do adding ticket scanning error rates. Def error rate self goes to int and return sum for ticket in self dot nearby tickets for n in ticket if not self dot valid for any field n, and I want to return the sum of all these n's, and now I want to assert that problem dot error rates equals 71. Okay, so let's try that and see if it works. That works. Okay, so let's say raw equals f dot read, problem equals problem dot parse raw, print problem dot error rates, and let's run it 22057. So that's the right answer. Okay, good. Now that you've identified which fields contain invalid values, discard those tickets entirely. Use the remaining valid tickets to determine which field is which. Using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If seed is the third field, it's the third field. For example, suppose you have the following notes. Class equals this, your ticket, nearby ticket. Based on the nearby tickets, the first position must be row, second position must be class, and the third position must be seat. You include the near ticket. Class is 12, row is 11, and seat is 13. Once you work out which field is which, look for the 6 field on your ticket that start with the word departure. What do you get if you multiply those 6 values together? Okay, so this is interesting. All right. Def discard invalid tickets self, which is none, and valid tickets equals t for t in self dot tickets if all valid for any field I for I in T. Self dot nearby tickets. Okay, and so discard, let's say, actually let me def is invalid self ticket, which is a ticket. You can see that I'm stalling and solving the hard part of the problem. Return for and in ticket, if not self.valid for any field and return true, it is invalid. Otherwise return false. And for ticketed if not self dot is invalid and self dot nearby tickets equals valid tickets. So let us try this and say that's good. And then let's say problem dot discard invalid tickets. And after we discard assert that problem dot nearby tickets is just going to be the one that's left, which is 7347. So let's make sure that's right. Let's see. Self.nearby tickets. Tickets. Can't set attribute because it is a named tuple. Okay, that's good. That's fine. I actually prefer this way. Return self dot replace nearby tickets equals valid tickets. I prefer immutable data, so that's good. And let's say problem 2 equals this, and assert problem 2. Okay. Got unexpected field names nearby tickets. Did I do the same thing again? Nearby tickets. Okay, so now that works. So it's doing the right thing, which is good. So now we need to do the following. No, I don't want to go to that. That was the wrong thing to click on. I want to go to Chrome. Okay. Once you work out which field is which, look for the 6 fields on your tickets that start with the word departure. What do you get if you multiply those 6 values together? Okay. So let us work this out. Let's call this identify fields, and we'll get a problem, which is a problem. And we're going to get a list of strings. And we're going to return basically what are the fields in order. And let's say num fields equals len of problem dot my ticket. So we just want to know what those are. Field names equals rule dot name for rule in self in problem dot rules. Okay, and problem your ticket, my ticket, my ticket, your ticket. Okay, and so now let us try the real naive approach, which is candidates equals set of field names for blank in range num fields. So candidates I is the possibilities for the ith field. Okay, so now what I want to do is actually that's not how I want to do it. I want to start with only the valid ones for I in range num fields. Okay, and do I need to include my ticket in there or not? That's an interesting question. So actually, I want to do the following and say tickets equals problem.yourTicket plus problem.nearby tickets. So I'm going to do that. And candidates I is the possibilities for the ith field. Okay. And what I want to do is I want to say, actually, I might not even need to do that. Rules are name tuples, so I don't even need to do this. I can just, that's the nice thing about name tuples is they're immutable, so you can use them as keys. So rule goes to, and then we're going to have a set which is going to, no, sorry, I got that wrong. Candidates is going to be rule for rule in problem.rules if all let's say yes, if all rule dot is valid ticket I for ticket in tickets. Okay. So in other words, if every ticket is valid for this rule, then we keep it. And what does it not like about this? Oh, this should be that, and then this should be that. I think that's right. Okay, so now I have candidates and print candidates and return this. So let's just see what happens if I run this and say identify rules of, what do I call it, problem 2? No. Identify fields of identify fields of problem 2, unhashable type list, yes. because this should be a tuple range and type tuple cannot be in, yes. R1, R2 equals ranges dot split on or, and ranges equals make range R1, make range R. What does it not like about this? Okay, so that says the first one could be either of those rules, and the second one could be either of those rules. So let me look at that problem and see what it says. So tickets are, that's one, and that's one. So once we've done this, it says the first one has to be 7, so it can only be that let's look at problem 2. Yes, so identify fields problem 2. The first one could be yes, got it. So it can be that one or it can be that one. The second one could be second one is 1 and 3, so it can only be that one. And then the third one is 14 and 47, so it can only be that one. Okay, good. So now what we do is the following. I want to say while true, and I should probably do it differently. Let's say unique rules equals rule for canned and candidates if len canned equals 1, for rule in canned. Okay, so that says find me all those candidate sets that have size 1, and if len unique rules equals num fields, so that means we have a unique rule for every field. Return rule dot name for canned in candidates for rule in canned. Okay. Otherwise, Otherwise, for I in range num fields, actually for I canned in, yes, for I in range num fields, canned equals candidates I. If len canned is bigger than 1, canned equals rule for rule in canned if rule not in unique rules, and candidates I equals canned. And hopefully that works. So now, let's try this again. Row class seat. Row class seat. Okay. And let's go here. Problem 2 equals problem dot discard invalid tickets. So let me run this and just see if this works, or if it gives me an infinite loop. Okay, that works, good. So let's say fields equals identify fields problem 2, and now what I want to do is I want to multiply the 6 values together. So we called those departure. And I want to import math. Say departure values equals n for name and in zip fields problem 2 dot your ticket if name dot starts with departure, and then assert that len of departure values equals 6, print math dot prod of departure values. So let's try this. It's a big number. All right, let's try it and see if it works. That is the right answer. 1 gold star, rank 459. So, yeah, so like, I'm glad this worked, because if it didn't work, I would have had to try something much harder. So let's walk through this. We have these tickets, and each ticket has basically 2 ranges, we have these rules. So a ticket has a bunch of fields on it, and we don't know what the fields are. We only get the numbers. And each field has a rule that says it must be in one of these 2 ranges. So class has to be one of these 2, and so on. So first I just started with my traditional data modeling stuff, right? So, you know, a range, I didn't need a name tuple because it's really just 2 numbers. It's just a tuple, int and int, a low and a high. And to make range from a string, this is just a parsing function. Since I'm doing it as a tuple, not as a name tuple, I can't do a parse function. So I split on the dash and just return int low, int high. Okay, easy enough. And then I have this rule. The rule has a name, and they gave me that in my example. And then it has 2 ranges. I start off with a list, but because I wanted to put these things into a set, I decided it was better to make it a tuple, immutable all the way down. That means I can stick it in sets. That's one nice thing about name tuples that, you know, I mentioned, right? So I know that a rule has a name, and I know that it actually has exactly 2 ranges, so I can represent that as a tuple range. And I could have done like range 1 and range 2. That would work too. And then I said, is valid. A number is valid if it falls in any of the ranges. So I just check with any, I is between low and high, where low and high are that range, and I just iterate over the ranges. And then again, I have my usual static method to parse a rule, and it's just, splitting on colons. And you saw I had to change this to make it a tuple, but there's nothing fancy going on here. They said a ticket is a list of ints, and again, because it's not a name tuple, I don't have a static method to add, so I just make a bare function that makes a ticket and puts that parsing logic there. And then, just for, I don't know if this is a great idea or not, but just to keep everything together, I made this class to represent the problem. A problem is some rules. It's a ticket for me, and it's a ticket for everyone else. So represented those in natural A. And then they had this logic that said, is a number valid for any field? Well, it's valid for any field if I can find some rule that the rule says I is valid. And so I needed that to do that. So that's pretty simple. And then later I wanted to say throw out the invalid tickets, and I say a ticket is invalid if it has a number on it that's not valid for any field. Okay, and I probably could have been nicer about like double negatives and triple negatives. Is valid versus n is valid. If not, self-valid return true. Anyway, this code could be cleaner. If I were, doing it for work, I would refactor it to make it cleaner, but I'm not. And then they just define this error rate, which says sum up all the n's in the nearby tickets if n is not valid for any of the fields. So I just did what they said. Double comprehension plus an if, and that's it. And then for part 2, it says I want to just discard invalid tickets. We have this invalid ticket helper, and so I basically just use a list comprehension that says, take the nearby tickets, make a list of valid tickets, and throwing out the invalid ones. And then because it's a name tuple, I can't mutate it, so I just return. This is how you basically make a new name tuple with one of the fields changed. So nearby tickets is valid tickets, and again the parsing is straightforward, nothing real surprising here. Okay, and so now the identifying fields is actually the interesting part of the problem, right? And so what they did is they said, I want to take these rules and figure out what field has to be which. Well, I say, first off, I know these 3 tickets are not valid, right? Because each of them has something that doesn't fit anywhere, right? So like, let's say this one. I know that well, that one's okay. Here's this. That one is okay too, and that one is those are all okay. Anyway, so there's no invalid tickets here, but basically what I do is I say, let's look at the first position, and I have 11, 3, 15, and 5. What could all those be, right? And so I say that one can't be seat, right? Because it has a 15 and 15 doesn't fit in seats. 11, 15, 3, 5 can all be rows, and 11, 15, 3, 5 can all be classes. So I say the first one is either class or row. And then I say 9, 1, 14, 12. Okay, well 14 can't be seat either. And so we know that this one's going to have to be seats, the third one. Although that's not actually how I solved it. That would be interesting. But what I did is I said, we have these n fields. Or let's start up here. I have some number of fields, and let's take all the tickets, my ticket plus the nearby tickets, to do what's valid. And I say, what's possible for the ith field? And so what I do is I say, for field 0, I want to keep only the rules that rule is valid for, the 0th, the first column for every ticket, right? And so that's what I did here is I said basically, for this 11, 3, 15, 5, seat is not a possibility, right? Because 15 doesn't fit seats. So I can't keep seat there. So I keep class and row, and then so on and so forth. And so I do that, and so what I do is I say I'll start off with just things that I know are possibilities for each of these fields, and then I enter this infinite loop. And what I do is I say, let's find all the rules that only appear or that appear in a singleton set of possibilities. So because each rule can only get used once, if I know that position 3 must be rule departure time, then I know that rule departure time has to be that, and it can't be anything else. So let me remove rule departure time from everywhere else. And then just repeat that, removing rules until we get down to I have a unique rule for every field. Now my worry was that that wasn't going to work, right? Because you could have in theory a set of these conditions where none of them are so like what I mean is this. Let's say I have and maybe I'm not right here, but let's say 1 has to be A or B, and 2 has to be either B or C, and 3 has to be C or D, and 4 has to be A or D, right? And so if I had something like, I mean, this isn't going to work, but if I had something like this, then I could say, I might have to reason like, and like this isn't a valid set, but here's the sort of thing I was worried about. If I were able to reason, you know what, because these two have the same things, A and D, one of them must be A and one of them must be D, and therefore this one can't be A, and it has to be B, and this one has to be C, and so on. So maybe that's not possible, or maybe they just gave us an input that's not a problem for. But I was worried that after I did this, that it wasn't going to finish, and it wasn't this process of just find rules that are uniquely determined and then eliminate those as possibilities for everywhere else. But it turns out that for these examples that did work, and so that's good, and that's what happened. So that's that, and that was sort of a long-winded explanation that I don't think was actually a really great explanation, but yeah. All right, that worked. I'm going to stop talking and go to bed. All right.